All right, my name is Adrian Jensen. I work with Applied CAX and Predictive Engineering, and we're back with another one of our FEMAP seminars. Today we're going to focus on FEMAP v12 and all the new features. So before we get into that, I want to introduce the team here. On the line with me, I've got Brian Kolb.
Morning.
And Ken Gollins.
Good morning.
Okay, so there's a lot of new features, and we definitely can't cover all of them in the hour or so that we have here today. So we went through and picked out some of our favorites, and then you can see more, the full list of new features in our attached documentation. But we want to do kind of a quick overview. The three of us will be touching on different models, but there's new geometry, creating geometry, also geometry cleanup, removing things, simplifying parts, basically creating a nice idealized geometry set for you to mesh. As far as the meshing goes, meshing toolbox is always expanding, getting new things there. There's a new way to display your mesh, hide mesh, but still showing lines. And there's a new mesh point editor, which is really good for, I see this a lot in aerospace, where you need nodes at certain locations for boundary conditions or fasteners, but you don't want to spend a ton of time subdividing your geometry. So this is a great little manager. We'll get into some general model management. There's a lot of new model management stuff, the way you can move, rotate, and copy entities, all grabbing geometry and mesh together, and then lots of fun stuff on the post-processing. So I'll get started on my end here, and we'll just kind of stick to the FEMAP sandbox here. So if I start a new version 12, this is the beta. This will be released very soon. I think they have plans within the next few weeks. One of the things that happens with the new release is we do a lot of beta testing, and any sort of little quirks that we find, we harass the developers and push them to get them fixed before the release. So it's a little bit behind schedule, but the goal is to get the best quality product out and not something that you as users will be debugging. So this is what the new interface looks like, and I want to start by comparing against the old, because one of the things they've done is really done a lot of speed increases, especially in geometry preparation. So if I import some geometry, I've got a PCB here. This is my solid CAD geometry. And I want to idealize this. I want to get rid of all these holes and just have node points there. First thing I'm going to do is defeature, feature removal under the meshing toolbox. There's lots of things here, and we've got seminars dedicated just to the meshing toolbox if you want to explore some more of these options. But I want to remove loops, basically holes from this. I turn on the meshing toolbox with the select button, and I'm just going to go for everything all at once. Now, one of the benchmark models that the FEMAP team used, they said removing the holes in the example they used took about 30 seconds with 11.4. Mine's a little bit faster, not too bad. But you can imagine on bigger models, it can really be slow, and those sort of delays, they really add up over time with a big model. So let's try it in V12. I'll import that same geometry. I'll go to the meshing toolbox, feature removal, same thing. I'm going to be removing loops. I turn on the meshing toolbox here, and to select multiple entities at once, I'm just holding the shift key, and that gives me a box drag. And you can see that's pretty much instant. So a lot of the commands in the meshing toolbox you're used to using that maybe had a little bit of lag, those things are going to be a lot faster in V12. Okay, so let's take the modeling on this printed circuit board a little bit further. I'm going to do a fresh start here. I'll bring this back in. Printed circuit board. I'm going to mid-surface the part. Mid-surface, automatic. We'll select everything. And for your target thickness, you always want to do something a little bit thicker than your thickest part. And we'll combine this into one mid-surface. Now, if you look in the model info tree, here's our original CAD geometry with the actual thickness to it. And there's our mid-surface geometry. That's what we're going to be putting the plate mesh on. So I can get rid of my original solid, just work with this here. Okay, so I want to remove all of these holes, but I still need points at those holes so I know where to put a node so I can attach my PCB to some sort of frame later on. And there's several different ways of doing this. We could create a point, use the center method, and walk our way through here, creating points for usage later on. But in each of our seminars, I always like to bring in something new and different. And the API that I want to present for this one does some of that work for you and folds in nicely to some of these new tools. So if you're not familiar with API programs, you don't have to have any programming experience. There's lots of APIs out there. FEMAP install actually comes with a huge selection here under custom tools. But this particular API I wrote creates points at the center of circular curves, and actually wrote it for this very application. So I can just grab everything here. It'll sort through, figure out what's a circular curve, what's not, and it'll make new points. And it's set up to create those in pink, so they're easy to see. So now I've got some points in my model here. Problem is, all of these curves get broken into two segments, 280-degree segments, and I don't want to have duplicate mesh points on there. So I got to get rid of some of these redundant points. I'm going to hide my solid using the DrawRace Toolbar. This is a tool that came in a few versions ago and is a nice way to show, hide, blank things really quickly and easily. And I am just going to make sure to get rid of any coincident points here. This is just like coincident nodes. We'll get rid of all those duplicates. Okay, so now let's remove the holes from the CAD geometry. We don't need those anymore. So I go into meshing, feature removal, loops, the same command as before. And sometimes I notice you get lucky, you can do the full thing. It knocks everything out. In this case, it skipped a few. It all depends. Nothing really works perfectly. So if you run into problems, you can always try a smaller bite of the model, knocking out holes a few at a time. Not too much slower, and it just gives FEMAP a little bit more granularity and being able to process. And now what we want to do, I'll turn off the DrawRace toolbar so we can see both our solids and our points, is we want to assign these points as mesh points onto our surface. So previously you'd go into mesh control and there was some options there, but the new way to do this is the mesh point editor. And they give you a little toolbox, just like any of the other window panes, kind of similar to the data surface table. And you can park it anywhere you want in the FEMAP interface. I'll put it right down here. And this is a way to help manage all of these mesh points, which before there was not really a good way to track all of this. I'm going to go on points. I will hide my surface so I can just pick these mesh points. There we go. Loads them into the table. Now you'll see there's a little symbol here to let you know that that's not just a geometric point, but it's being used as a mesh point. And some of these, this radius created a point out here. There's no symbol there. It doesn't fall on the geometry. So that one doesn't get as included as a mesh point. So now let's set some sizing on this surface. We'll go with the default. And we will mesh this surface. You can see there's some more shortcut options here in V12 for setting up material orientation if you're working with orthotropics. I'm trying to create some easier shortcuts here as far as workflow. All right, so this is going to be kind of a generic isotropic printed circuit board. And we'll just come up with our own material properties here. Okay, so creating my plate property, there's my thickness, and we will mesh. Now, one of the keys to this mesh point on surface is having a good mesh density. Though you'll see in the help section, they recommend you want a relatively high mesh density in comparison to the amount of points, because what it does is it just takes an existing node on the mesh and moves it to your mesh points here. So if your mesh is pretty coarse like this, you can end up with not the best quality elements. So in this case, I'd probably come back and refine the mesh either by resizing it or using our friend the meshing toolbox. You can see as I update size on curves, these mesh points stay anchored. So I'll always have a node where I need it for fasteners, boundary conditions, and so on. Now, if I want to get rid of some of these, there's this little nest here, which actually corresponded to some openings. I can view the labels of these mesh points. And let's just take a few of these, for example. We've got 93 through 96. So rather than having to delete these or remove these from the model, I can just go into my little editor here and turn off 93 through 96. And let's remesh this surface. We'll delete the existing mesh. And those are no longer mesh points for this surface. So it's no longer going to push a node to those points. If you want to bring them back later on, you can turn them back on. So there's a lot more options in this mesh point editor. One of the really nice things could be working from loading from a file or saving from a file. Maybe you have an Excel spreadsheet with the X and Z coordinates of all your fastener locations. That way you don't even have to create points. You could just load that or paste that from the clipboard. There's lots of options here. So when this is released and this is something that interests you, I recommend digging into the help file, kind of seeing all the options, and let us know. We're always interested to see how our customers use these things. All right, switching gears a little bit, I've got another geometry preparation example, and I think this one is so nice because I've really suffered through creating beam element models a lot. We really like to use beam element models whenever possible. They're fast, they're efficient, they're great for post-processing. But sometimes starting with CAD geometry like this, you can see all these various solids here. It takes a lot of work to create the center lines for all of these beams, making sure they all connect and break at the intersections to share nodes. It's quite a process, but what V12 is introducing is geometry curve centerline. So what this is going to do, we'll apply a material. Let's create some steel tubing material. We're going to apply this to all the geometry that I'll select here, and I'm just going to select solids. Holding down that shift key gives me the box select. Okay, and we're done. So what did it do? Let's use the DrawRace Toolbar again. I'm going to set it to erase mode. You know it's turned on when it's green. So I'm going to erase all of these solids. Now you can see the curves that it created. It created curves at those center lines. And if I turn on thickness, you can see it's assigned a tube property to each of those curves. And if we look in the model info tree, we've got beam properties based on the original solid geometry. So this does a lot of work for you as far as beam modeling goes. There's a few things. Every program has its limitations. You can see some of these intersections haven't totally connected, but we could use extend to reach these curves out to an intersection point. Let's snap to point. That brings that out there. There's a few other things, like I'll notice the intersection of a curve. We need a break there to make sure that these two curves join. We can use another new command. Modify break now has the option for all intersections. So we just go in all of these guys, let them self-intersect. Now when we look at these curves here, we can see we've got a break. So we'll have merged nodes. So really the only thing you have to do to your model after intersecting your curves and using that centerline finder is give it a size along curve. We can go with a size like this and mesh those curves. Now it also finds the orientation. So if we were working with something that wasn't axisymmetric, like a tube, we had an I-beam, it would figure out the orientation of that. There we go. We'll probably need to check coincident nodes at intersections like this. Seems to merge up pretty well. Like I mentioned, there's always a few little, you can see we got a few little things overhanging there. So there's a little bit of cleanup done, but I'd say this cuts down the workflow pretty drastically. All right, so that's kind of a few of my favorite new features. Yeah, we got a question. Ooh, okay, so if you guys didn't hear that, somebody was asking, going back to the mesh point, did they remove rays or change the limit on the number of mesh points you can have on a surface? I'm not sure about that. I'm assuming since they did a pretty complete overhaul on this, that they've expanded that capability. But I'll dig into that. We'll do another one and push the number of mesh points to the limit, see if we can get something weird to happen. So with that, I will pass it off to Brian. And we'll check out some of the other new features.
All right. All right. Can everyone see my screen okay? Looks good. Awesome. All right. So I'm going to talk today a little bit about some meshing features and some of the copy, rotate, and reflect move commands, some of the new things they've done there. So I'll start out, I'll run through a little example where I'll copy geometry, and then I'll run through an example where I'll copy the mesh. I'll show you a new display option for meshing, for meshes. Then I'll talk about some new features, or a new feature in the merge models command, and then show you a real handy new feature from the meshing toolbox. All right, to start out here, I have a model, just sort of a generic tube with some holes in it. I'm going to use to display a few of the features. I've got a load applied to the surface here, just a 1 psi pressure load, and I got a fixed support applied to the surface there. So you can see, just a simple geometry. All right. Okay, so to start, we'll show you the copy geometry commands. So you geometry, copy, and we'll copy solids. So I'll select this one here. And we'll take a look. And the first thing you can notice is that the toolbox itself looks quite different from the old version. The old version looked something like this. You had color, you could copy your mesh sizes, loads, constraints, repeat, pretty generic. Here you have a lot more options, which is nice. So for here, it used to be you could just copy along a vector, but now you can move to a location, you can copy between coordinate systems, which is a real handy feature that I'll show off here. You can also copy between vectors and between planes. You can include the mesh, same as before. But you can either duplicate properties, use the same properties, duplicate materials, or use any sort of property you want, which is kind of handy. And you can actually individually select loads, constraints, or both, which just gives you a little more options. And over here again, you can make multiple copies, repeat, copy in the same place. You also have this pattern option, which is pretty handy. It allows you to copy in the X, Y, Z directions, use spacing, number, and whatever vector you want. So let's see here, get back to geometry, copy solid. All right, So to start out, we're going to just copy that solid, and we're going to move between coordinate systems. We'll include the mesh, the same properties, loads, constraints, and that's all we need from here. So when we hit OK, what I had done initially is I'd set up a cylindrical coordinate system over here, and then I basically reversed it. And so the nice thing about this coordinate systems, moving between coordinate systems, is you can kind of use copy now to reflect, rotate, move things all over the place by defining your coordinate systems. So for this, I'll just go from my first coordinate system to my reversed, click OK. There you go. Nice and easy. Everything is copied. And we've got geometry. And it's created a new surface load. And there are no constraints on this side. So, things. All right. So that's pretty much, the main changes for geometry. And now we'll go ahead and copy using the mesh command. So if you go mesh, copy element. For this, I'm just going to use my method in solids to make things easy. So I'll select the remaining solids, click OK, and again, a very similar dialog box comes up. One of the new features, which is really nice, is you can actually copy your geometry just by selecting mesh. That wasn't the case before. I believe the old meshing toolbox, something like this. You could grab loads, constraints, regions, elemental loads, constraints, regions, and you could either choose to match original or you could select another property. Not a ton of options. Now you can actually do geometry. Again, you can select loads and constraints individually. So what we're going to do here is we'll move between coordinate systems. I'm not going to copy the geometry because I just want to show off another handy feature here. It's pretty self-explanatory. What is nice is this thing will actually take the loads and constraints from surfaces and apply them to nodes and elements, which is a real handy feature. So if you click OK, again, same system. There you go. So in this case, we have no geometry, just mesh. But what is nice is if you come down here, you can look, the pressure load has actually been applied to the elements. So they've taken that pressure load and converted it to element. And you can see it works as expected, which is really, really nice. Also, it's added nodal constraints, fixed constraints. So that's an incredibly nice feature. They didn't have that option before. So if you either had to define everything elements when you're working geometry, or you had to go back and do it afterwards. All right, so now we'll go ahead and cover a new little feature they have for just sort of displaying, display feature for the mesh. Go ahead and oops. So I'm going to turn shading off. So we have this new silhouette lines, if you will. If you open up your view options and you come in, you start to the tools and view styles, there's this feature line option. And if we come and choose to draw there and we go all elements silhouette, you can basically choose to apply, well, I'll show you here. I'm going to set an angle of 50 to start. You hit apply, it highlights all the, it highlights the edges of the element and the breaks at that angle. So you can actually adjust the angle depending on what you want to see. Like if I lower it, it looks a little funny, but it's going to basically kind of allow you to choose, display the different angles and breaks. Just a nice way to show things, especially when you're dealing with just mesh. A lot of times I try and turn curves on to get a better visualization, but it didn't work so well. So that's just a nice new feature that they have for displaying things. So I'll click cancel on that. All right, finally, as far as copying goes, they have a really nice new feature. Before, there was this file merge, which was used to basically merge one model into the next across models. But now they have this copy in current model, which basically does the same thing as merging, but you're actually copying it in the same model, obviously. So you have most of the same selections. You have a few new ones in options, but you do now have the option to move along a vector, between vectors, rotate, between planes, reflect, between coordinates. So it's just a real easy way to choose if you want to transfer, what is you want to copy or what do you want to move, and do that all at once, which is pretty nice. All right, and so also as far as the rotate, reflect, move, those commands are going to be similar. New dialog box gives you the same options here, allows you to grab the mesh with loads, and that's going to be the same. This type of options are going to be the same for the move, and then mesh, of course, is going to give you that option to grab geometry as well, which is nice. All right, now we're going to go ahead and talk a little bit about one of my favorite new features, and that's in the meshing toolbox. So before, if I wanted to come in here, add sort of a washer, pad, what have you, I would have to, individually, I'd have to slice individually all these different areas and go ahead and mesh them together. It was a big hassle. Takes a lot of work to go through and clean up solid models. Previously, when if you're surface modeling, you have these washer and pad features where you can come in and just select it. We never do that before. Now, they've added the option to use those washer and pad features for solids and non-circular loops. It's incredibly handy. So to show that off, we'll start out with washer, distance, let's just do 0.1. And even though these are circular holes, they're on the radius, so you're going to have to include non-circular loops. And then when you're working with solids, you want to make sure to select split solids. And we can just come up here, over to one of our holes, just like you would with the surface model. Select, takes a little while. But it'll get there. And there you go. You get a nice washer built into your solid, real easy, one step, very nice. You can also come into really non-circular holes like this. We have the square. Geometry sides are here. So let's lower that a little. 5. And we'll select that guy. There you go. Puts a nice little washer on that. So what that's doing, which is nice, so on non-tangent corners, it performs different splits on the insides and outsides to create the best possible mesh. So this shows the surface again, but it's going to be doing something similar to this whenever you're working with any type of hole. Also works the same for pads. Come in, distance 2. Make sure always split solids has to be on when you're working with solids. And we can click this guy here. And look at that, nice pad. So just like when you're working with surfaces, now you can do the exact same thing for solids. Again, you can add a washer if you want. You can go through, grab multiple at once. But again, this is probably one of the features I'm more excited for because it's going to save me a lot of time. So that pretty much wraps it up. There's a lot of other features I recommend kind of exploring more and playing around with things. Just a lot of new great features that just make life a lot easier. So
hey, I got a couple of things to add on there, Brian. So first of all, anyone who's been using FEMAP a long time and suffered through hex meshing, like this is a game changer. This is really nice. When Brian and I saw this presented at the symposium, we're just like, wow, this is great. A couple of things. So with all of the copy rotate commands where you can grab mesh, it brings geometry, grab geometry, it brings mesh. I wanted to mention that also works for moving and rotating. So it's not just for creating new entities, but you could move existing entities. So if you've got mesh and geometry and you want to move both of them together somewhere, they've expanded the move by under modify, the move by and rotate by options to include those associated entities. And same goes for the mesh points. That was one of the things with the old mesh points on my example is, all right, what if I need to move this? Now I need to go move all those mesh points as well. So the new version takes that associativity between parts to a lot of different entities and commands. And then the other thing I wanted to ask you about before we move on, with the silhouette command, I think I saw some image where you could hide the elements but still look at the silhouette. I'm not sure exactly how that works, but
let's see if I have not explored that feature. let's see.
Nothing like a live curveball to
Oh,
like
there you go. Right.
Oh, okay, cool.
So it does work somewhat. Kind of shows you the different.
Yeah, and I thought this was useful, or if you need to hide some elements, but you still want to figure out where you're at in the overall structure. Maybe you can use DrawRace Toolbar to hide some elements and still see the outline of them. This is pretty nice.
Yeah. Yeah, lots of new handy features. So.
Awesome. Thank you.
Yeah. All right, I'll go ahead and hand it over to Ken, and he'll finish it up for us.
All right. Thank you, Brian. Can everyone see my screen? Yep. All right. So I would like to show some of the new post-processing features that are quite handy if you want to explore some of your results from your analysis. So the first thing I'll be talking about is how to view the thickness of all of your components. So here we have a shaker screen with a lot of different plates that have various thicknesses. So previously you could go back into your model info, into your properties and right click and edit and just verify your thickness. However, in FEMAP v12, we can go over to this model data contour, turn on show model data contour, and click on plane element thickness. And now what this will do is bring out a nice contour plot of all of the thicknesses in your model. However, this default view isn't the most intuitive way to view all the thicknesses. So if we go back into model data contour and turn on our discrete values, we can create a new view set. And what this will do is bring in all of your properties. So here we have 17 different plate thicknesses. And if I click OK, it'll give you a range of all of the different thicknesses and color options. So you have the opportunity to change the color as you please. For now, we'll just leave it as the default. And when we click OK, click OK again, now we have every single plate here shown as a different color according to its thickness. Now, this is really nice because you can go through and verify that everything is as it should be and you don't have any errors. So now, another new feature in V12 is that you have these interactive screen entities, and what that does is it allows you to move all of the different legends and axes on your view screen here so you can place them where you'd like. A new handy feature with that is if you click on this the global coordinate system here, it'll bring up this view cube, and you can click on the front to get a nice front view, or you can rotate to see the corners to get a perspective view. And as I was saying before, you can move these all around by just holding the left click key, and you can move this around as you please. You can also move any of the text around to show what you're currently looking at. You can also move the legend key around here as well. So let me go ahead and turn on our stress contour. So we can do that in our post-processing toolbox, the drop down here and click contour. Let me turn off the thickness first. Okay, so now we are looking at the von Mises stress from this analysis of the shaker screen. And as I was saying before, we have interactive abilities with these legends and contour data. And with this, we can click on the top value here and we can set the minimum and maximum. So let me go ahead and change that to 4,500 PSI. And additionally, you can also click on the bottom here and let me go ahead and set that to 0. So now we've altered the scale and we can get a good view of where the stress hotspots are. Additionally, you can increase the number of legend scales here, and you can decrease them as well. And this can also be moved around, and you can, oops, got stuck. You can move it to the top and it will adjust its view in the horizontal position, or if you like it vertically, you can do that as well. So now another really nice feature for viewing stress hotspots is the dynamic criteria. So what this will allow you to do is just isolate those key points where you're seeing high stresses. And this can be done by going to View, then to Advanced Post, and into Dynamic Criteria. So here we now have the options to set the criteria to be above a certain value, or we can select it to be below a certain value. Let me go ahead just for the demonstration, just to do above. Whoops. It doesn't like it if you click anywhere else off of this dynamic control here. So you can adjust this slider bar and you can see the elements fill in as you adjust this value here. So let me go ahead and zoom in on this point here. And we can see all of these elements start to fill in. Okay, and let me add that the dynamic criteria can also be brought up through the post-processing toolbox. Let me just clear that out. So it's in criteria, and if you click the button next to dynamic control, this will bring up that same screen. Oh, one thing I forgot to show before with the interactive entities is if you hover over, you'll see this button that kind of looks like an upside down eject button. If you click that, it gives you direct access to the view options screen where you can change all of the colors and anything else that you please. This is also opened with the F6 button. Okay, so another handy feature that you may want to use is the report generator. So that is found in Tools, Report Generator. Now I should add that you will need Microsoft Word for this to work because that is where it exports all of the data to. So you can go ahead and give your report a name. We'll just call it Analysis 1. Oops, Analysis 1. We are Predictive Engineering. And from here, you can select all of the entities that you would like to be pulled into that report. So you can select all of your load sets, your constraints, your connections, your outputs, and your groups. And you also have the ability to change how the pictures will be exported. So you can set a certain picture size for each image, so that way everything is uniform. So let me go ahead and click Create Report. This might take a few seconds. This just gives you a nice way to export all of the data into one place so you can see all of your model info, such as your material properties, your loads, your constraints, and it'll give you images of all of your stress plots. Okay, here we go. So oops. Let me go ahead and show my full screen this way. Word will come up. Okay, so now what this brings in is all of the information about the model, as I said before. So you can see all of your geometry. This is the name of names and info such as volume, number of elements inside all of your solid bodies here. Should show all of the plates as well. Here's your mesh info. You have the element type as well as the number of elements associated with that. It gives you the total number of elements, total number of nodes. Gives you all of your materials. Now, I will say this isn't the prettiest output, so you might want to go ahead and just reformat that as you please. You can see all of your loads. Now, it will take a screenshot of your current view. So if you see here, this is what we were just looking at in FEMAP. And then probably the last helpful feature of this is in your results summary. It'll show you your maximum von Mises stress and anything else that you select in there, and it'll give you stress plots. This didn't work out so well for this demonstration because the view is a little weird, but you have full control over what views you would like to be in there. Okay, so that about wraps it up for the new post-processing features. I will send this back over to Adrian to wrap everything up.
Yeah, excellent. Thanks, Ken.
You're welcome.
Okay, so that pretty much covers what we wanted to talk about today. I think we got all the questions there. Move by, legends. So you can see that a lot of this stuff is much more interactive now, and you're not digging into some view setting option buried 5 levels deep. you just click, you get those options right on screen. So there's some more things that, some geometry additions that they've made and some solver support that they've made. What I recommend is when this new release comes out and you install, there'll be a what's new with every single improvement they've made. I think what we showed here today was probably our favorite and most useful stuff, the things that we'll be using on a daily basis. And then as far as graphics, overall speed improvement goes, that just works out well for everybody. Okay, so thanks for your time. If you guys have any questions, you know where to contact us. And like I mentioned, the recording of this, along with some of our models, examples, APIs, and this little outline here will be available on appliedcax.com. All right, everybody, thanks for your time and have a great week.